So today I'm going to explain you my project, final project, tall building design project assignment for Skyfi Labs online course. So first of all, let's go to the grid and let me show you the grid properties. Here we have tall building with different sections. First section extends from story 1 to story 8. The second from story 9 to 14, the third from story 15 to 19, and the fourth from 20 to 23rd. There are four cross sections at different levels, and the grid we have this grid with 6 meter spacing in x and in y direction. This is building is designed is having 22 floors plus G ground floor. So first of all, we'll define material properties, which is M40 for concrete, HYSD 500 for longitudinal reinforcement, mild 250 for curtailment and shears. Next, we'll define the section properties, and section properties, first of all we'll define the frame properties. So here we have defined our beams, three types of beams with cross section 500 into 300, 550 into 350, and 600 into 400. And we have also defined three types of columns: 350, 500 into 500, 550 into 550, 600 into 600. So in this we have also defined this thing known as beam auto. This is an auto select list. You can see it properly. So in this beam auto, we have all the three of cross sections which we have defined. So while analyzing, the system can take the most appropriate or the minimum value which does not fail on application of load. Similarly, we have this column auto. It has all the three columns, and the same thing happens for it also. The next we'll define the slab. So the slab of 150 mm is defined with slab material of M40 grade concrete and thickness of 150 mm. So now we'll start the modeling. First of all, we'll go to story 1. For story 1 or till 8, because these are the similar stories. Okay, we'll story 1 plan view is here. We'll select similar stories from here and we'll start the modeling of the project. So we have selected similar stories. So when we draw a frame structure, it will draw this frame structure from story number 1 to story number 8, because they have the same cross section. They are similar stories basically. So first of all, we'll draw the columns. We will go to column setting. We'll select our desired properties which we have defined, column auto, and we have a shortcut. We can select the whole in one go and draw it. After drawing, then we'll select this quick draw beams and select the required property which we have drawn, beam auto. After selecting, we can draw the outer and inner beams for this. The third comes here, quick draw walls, floor and walls. We'll select here and draw the slab. Select the slab property which you have defined, slab 150 mm. Selected, the area will be highlighted. Left click on it, and the slab will be drawn for the whole all the similar stories. Next, we will go to the next section, uh, which is or you can go from here. Not elevation, we need plan. Sorry, plan 8 we have drawn. Now you can go to 9. Apply. Okay. So this is the second cross section. The similarly as you have done in that the previous cross section. You have to do similar things for this, and this will also be drawn. Similarly, you go higher for different other cross sections. The third type of cross section, which starts from story number 15. This is the cross section. So similarly, you draw this. Then the last of the cross section, which starts from story number 20, 20 for 20, 21, and 22. This is the cross section. Similarly, draw this. Now, after drawing all the cross sections, we draw the auto cladding. Here we have the auto cladding, draw auto cladding option. Use floors and click OK, and this auto cladding will be drawn. Here we have not drawn any shear walls or partition walls. We have drawn auto cladding. They don't have they are helpful in applying wind loads, as in this project we have applied wind load. They don't have any self weight, while we but in this project we have considered a self load of for cladding as 0.2 newton per mm square. So now, after selection, putting all this and creating the cladding, now we'll assign loads to the structure. Now we in this we have different loads for the different cross sections of the building, but the dead load is same. So first of all, we'll apply the dead load. We can go here, select object type. You can uh, select floors, select all the floor sections will be selected. Now go to assign frame shell loads. All the slabs are shells, so we'll go in the shell loads. Shell loads and assign shell loads uniform and dead load, and we have type the value and click OK, and the dead loads will be applied on the structure. You can see the dead loads from here. Displayed frame loads, dead, span, apply, OK, apply. Display. Oh, shell loads. Okay. So this is the dead load provided on every section. You can see. So for the last section also we have 2 kilonewton, and for the first section also. And now we have also applied live load on it, which differs. So for live load for the last section we have 3.5. For this first section we have 5. So it differs for different sections. Then we have frame loads. This is the cladding load, which we have applied on the frames. Now we have the lateral loads, wind load. We have wind loads or the transfer lateral loads. So we have to go into the 3D view. So now go to shell loads again. Shell loads, wind load. Oh, this is frame load. So shell loads. This is shell load. Go to wind. Okay. So here we have the wind load. Point. This was taken from the IS code value according to different criteria given in it. This building is supposed to be established in Bangalore, so all the criteria was taken according to Bangalore city. So this is in the leeward direction, windward direction, 0.8 positive. In the leeward x direction, we have minus 0.25, and we have minus 0.8 and minus 0.8 for both the sides in y direction. So this was all the loading cases. Here in 3D view, you can also see special notes. So here, let me expand it. Here, this is positive x direction. So we have 0.8 W acting in x direction. So after applying the loads, we go to the plan base here, and now we have to provide restrictions to the base joints. So for all the buildings, mostly the base is fixed. So select the cross sections, all the cross sections, all the joints. Go to assign joint restrictions and provide uh, fixed. This is fixed, pin, roller, and free. Provide fixed and click apply. So fixed footing foundation will be applied to the building. Now we have done everything. Now we'll go to and analyze. It's the building. It will take some time, so wait. So we have got our results. Some maximum displacement 0.0996 at this location, and minimum is minus 19.178. And this is these values are in mm, so it is very less. Now to see better, go to the 3D view. So this is here we can see while analyzing, using auto meshes are created and the deflections are shown. On putting the cursor on any element, you will get it's all details. U in x, u in y, u in z, rx, ry, rz, and element number. So uh, you can see different shears and movements in. So these are the shears, those shear values for different numbers. You can also see the moment values. We select moment 33. This is the main moment. So these are the moment values. You can see. We have also display options, different shape, process to show everything. These two are the major checking. Here we have combos. These are combos for concrete design. These are for slab. These are for shear walls. These are case. You can go for case or for combo. Check it. And there is a story response. So this shows the maximum and minimum is between story all stories. You can change the load cases, all stories, load combination, maximum displacement. You can go for shear, story shears. This is in the y direction. This is for the x direction. You can go for movement, maximum story displacement, lateral load diameter, overturning moments, story overturning moments. So this is the maximum moment at the base. After that, we'll go for designing concrete frame. We design it for start design check. Now here the use of auto select will be utilized. Mm, okay. So now the analysis has been done. We can see the design output in terms of bar percentage. So this is 0.29 for beams, for columns it is 0.8. So everything is designed. Now see the plan view. Okay. So for columns and beams we have the percentage, reinforcement. Now we'll design. We have designed, so check verify all members are all pass. So your design is okay. Now you can go for detailing. This is the latest version of eTabs 2009 eTabs 19 version 19. So it does not have detailing option in within it, and otherwise you would have a detailing option here. For detailing you can save this drawing and go to CSI detail. From 2019 on from 19 version onward we have different CSI detail for detailing. The eTabs app itself does not have the detailing option. You can open the EDB files, which is G plus 22 final. Now it opens the eTab. Now data extraction is being click OK. Now your details will be generated. This is for the top load story 23, and similarly all the details will be drawn. Save the detailing. Okay, and your project is complete.